All right, mathematicians, I had a few questions come in about finding the area of composite figures. So I thought I would do a quick run through of the practice, just so you can kind of see my thinking as you work your way through. Does not mean that these are the only ways to do the problems, but to keep the video manageable, I'll probably just do one for each one. All right, well, with number one, it's pretty straightforward because the line is drawn in for you to show you how that composite figure could be looked at. So when we look at number one, what we see is a rectangle and a triangle, and those two pieces are put together. So what I'm going to do is I'm going to find the area of my rectangle first. So the area is going to equal base times height, or 4 times 12, and that's going to be 48 centimeters squared. And then I'm going to find the area, so that was my rectangle. And then I'm going to find my triangle, which is going to be base times height divided by 2, or 1/2 base times height. The base of my triangle is going to be this line right here, so that's going to be 12. So it's going to be 12 times 4. And then we're just going to divide that by 2. And then if you notice, really what this is another way you could have looked at it, is we could have actually duplicated that same rectangle that we had on the bottom, and use that and then just subtracted out the triangle. So like I said, multiple ways to kind of look at these. But here, so 12 times 4 is 48, divided by 2 is going to be 24, and then we're just going to take those two and add them together. So we're going to have 48 plus 24. So our total area should be 72 centimeters squared. Okay, so moving on to number 2, we see this kind of L-shaped figure. So what we want to do is we want to think about how can we look at this figure and how can we take out the different pieces or separate it. So one possibility is I could cut it into 2 rectangles this way, in which case I would have a 9 by 5 rectangle and then a 10 by 4 rectangle, and I could add those together. So if you want to think about it that way, it would be 45 and 40 put together, so you would have 85 centimeters squared. That's one way. I could also, if I didn't want to look at it that way, I could have separated it this way, in which case I would have a 5 by 5 rectangle, and then I would have a 4 by 15, and if I did that, this would be 25 and 60, which would still give me 85 centimeters squared. Or the last way I could look at it is I could actually make this one big rectangle that is a 9 by 15, and then subtract out this 5 by 10 piece right here. So in that case, we would have 9 times 15, which would be 135, and then we would subtract out the 50 from the 5 by 10, and we would still get 85 centimeters squared. So 3 different ways that you could look at number 2. All right, number 3. The way that I look at this, well, there's a couple ways you can look at it. One, you could see that it's just a rectangle and a trapezoid, and put those together. The thing for that is that here you'd have a 17 by 5 rectangle. So we would do 17 times 5, and that's going to give us, 85 for that rectangle. And then for our trapezoid, because its base actually stops here, we have to take off 5. So this length would only be 21 yards. So we would have to do our 7 plus 21 to add our two bases, which is going to give us 28. And then multiply that by the height, which is 17. And then we have to take all that divided by 2. So we would have 28 times 17, which would be 476. And then we take that, divide it by 2. And that's 238. And then I would just take 85 plus 238. And that's going to give me an area of 323 yards squared. That's one way you can do it. The other way that you could look at it is we could actually just make this, once again, a big rectangle that's going to be 26 by 17. And when I multiply those, I get 442. And then I'm going to take out this triangle. So that means I'd have to take the 26, subtract 5, which would give us 21, minus 7 more, which would give us that this length is 14. So I would have to subtract the base of the triangle, which is 14, times the height of the triangle, which is 17, divided by 2. So if I do 14 times 17, that gives me 238. And I'm going to divide that by 2. So that's 119. And now I'll do 442 minus 119. And I get my 323 yards squared. So that's a couple different ways that you can look at number 3. All right, so moving on to number 4, this is our kind of 7-8 level question. So you're taking what we've talked about and kind of going above and beyond and applying it in an unfamiliar situation. So here we have Mr. Basil is putting in a pool for his summer, and he has to tile around the pool to help keep it clean and safe and things like that. So the shaded area is the area that Mr. Basil wants to tile. So the first question that's being asked is, what's the area that he needs to tile? So what is the shaded area? So here, when we look at this, we have this large rectangle. That's a 12 by 10, which is what, when I was looking through your work, was a lot of you used that and you got 120. Now, if Mr. Basil was tiling this entire thing, he would need 120 square feet. But the part that a lot of you forgot to consider is that this inner part here is the pool and isn't getting tiled. So we have to take away from 120 the area of the pool, which is 6 times 8 or 48. So in the end, he needs to take 120 minus 48. And when I do 120 minus 48, he needs to buy 72 feet squared of tile. Right. So if tile comes in packages that cover 25 square feet and each package costs $30, how much would it cost for Mr. Basil to tile his pool? Well, since they come in packages of 25 square feet, he's not going to be able to buy exactly 72, so we have to figure out how many times we have to buy it. So our closest multiple of 25 to 72 would be 75, which would be 3 packages. So he's going to have to buy 3 packages, each that costs $30. So Mr. Basil would end up needing to spend $90 to tile his pool.